Undamped natural frequency and damping ratio is the subject of this video. If an S-domain signal has a pole or poles, then those poles will be one of these four: non-repeated real, repeated real, non-repeated complex conjugate, and repeated complex conjugate. The fourth one is uncommon and is not considered in this course. Since a transfer function can be defined as the ratio of two signals, a transfer function also has poles. Non-repeated pair of complex conjugate poles is the subject of this video. For example, the pole S is -3 plus J4, the same as 5 at an angle of 2.21. That's one of the complex pair of conjugate poles. The other is -3 minus J4. So there's a pair of complex conjugate poles. The factors from which those poles came are: create two binomials by putting S plus 3 into one term. The product becomes simple and the real and imaginary parts are still obvious. This may be the simplest expression, but the poles are no longer obvious. Several different ways of describing complex conjugate poles exist. For example, the transfer function 25 over s squared plus 6s plus 25 can be the ratio of two signals or the output-input relationship of some linear system. A standard second-order transfer function form matches this example. Omega n squared equals 25, therefore omega n is 5 radians per second. Two zeta omega n is 6, therefore zeta is 0.6 and it has no units. Omega n is undamped natural frequency. Zeta is damping ratio. Undamped natural frequency omega n and damping ratio zeta have been introduced. You can expect to see these many more times over the next 12 months.